As E increases, right up here, the reaction becomes more spontaneous. Delta G becomes more negative, and it proceeds to the right, decreasing the amount of iron ions and increasing the amount of tin ions. A decrease in products results in an increase in E, making the reaction more spontaneous. Since the reaction is now more spontaneous, there will be a decrease in reactants and an increase in products. It is important to note that the reaction is not in equilibrium as long as current is flowing. E is not equal to 0. Using Le Chatellier's principle to describe the change in reactants and products is not a valid justification. Justification must involve a discussion of Q being positive or negative, becoming E greater than or less than E0, and the resulting change in spontaneity. When responding to similar free response questions on the AP Chem exam, it is expected that answers are in terms of the reaction quotient Q, which is illustrated right over here. In this scenario, Q is less than 1. When Q is less than 1, then E is greater than E0. Q is less than 1 because the concentration of tin is less than that of iron ions. In comparison to standard conditions, there is decreased product or increased reactant. This is a slide that you should pause on. It shows the standard conditions and non-standard conditions for the zinc copper galvanic cell. So here's our equation. We have our values for E0, delta G0, and K, couple equations, and then 4 columns. One is for farther away from equilibrium than standard conditions, one is standard conditions, one is closer to equilibrium than standard conditions, and finally at equilibrium or the cell is dead, used with permission from over here, chem teacher in Charlottesville, Virginia, Mr. Michael Farabaugh.